I request all of you to switch on your video. Renu Madhavi ma'am. Good morning, everyone. I welcome all of you to the occasion of SigPro 2022, hosted by IEEE Bangalore section. So we had planned to arrange the project expo from the Bangalore section, and initially we had over 35 registrations, and then in the first level we have actually selected only the top 14. Only the top 40, and now we are here today for the final judgment of the projects and to select the projects for the prize distribution first, second, third. So I request HOD ma'am, Renu ma'am, are you there, ma'am?
I'm there.
Yeah, ma'am. Kindly switch on your video, ma'am, for some time, only for recording. I think Murli sir is going to join.
Madam, I have some issues with my camera driver. It's gone bad since the day before yesterday.
No problem, sir. No problem, sir. Only 2 minutes. After that, we will switch off.
Yeah,
only the member who is presenting will be switching on their camera, sir. Only 2 minutes. Okay, I would like to welcome Mr. Murali Mohan, sir, for this project expo as a jury member. So I would like to read his biodata. Murali Mohan Deshpande, sir, is currently working in the NXP Semiconductors in the Connectivity and Security Group. Murali's career includes several technical and management positions at various organizations, including Texas Instruments, Infineon Technologies, Philips, NXP Software, and Novels, India, working on embedded software development for IoT, mobile proximity or touch solutions, DSP architectures, algorithm design and implementation for more than 24 years. Murali has an extensive industry and software experience, and he has extensive expertise in voice processing and noise cancellation or suppression technologies, as he was actively involved in research when working as a director for algorithms and platform engineering at Novels India, the industry's leading provider of high-performance audio solutions before joining NXP. Murali holds a master's degree in engineering from Indian Institute of Science, Bangalore. He also stands out for his ability to productize core research ideas and holds 15 publications as well as 8 issued and pending patents with Upsto and Opto. It's my privilege to welcome you, sir.
Thank you very much, madam. Yeah.
Okay.
It's my privilege.
It's my privilege.
IEEE Bangalore section.
Thank you, sir. Thank you so much. It's my proud privilege to introduce Dr. C.H. Renu Madhavi ma'am, professor and head of the in Electronics and Instrumentation Technology, RVCE Bangalore. Dr. C.H. Renumadhavi ma'am, working as an associate professor and in the Department of Electronics and Instrumentation Engineering at RV College of Engineering, Bangalore. She has completed her MTech in Electronics and Instrumentation from NIT Warangal and PhD in the area of heart rate variability from Avinash Lingam University for Women, Coimbatore. She has over 30 years of teaching experience and she has involved in various academic activities like curriculum framing, and she has coordinated AST-sponsored one-week FDP on PIC microcontroller in 2008. And her research areas are biomedical signal and image processing and IoT. She has around 40 research publications in various national and international journals, conferences, and Spring book chapters, Willy book chapters, and IEEE Access Journal. She was a reviewer for various IEEE conferences and few journals. She was elevated as IEEE senior member in February 2020. She is a champion member of IEEE Move India Operations Committee 2021. She has contributed to NPTEL Swayam e-books translated to Telugu on courses titled Integrated Circuits, MOSFETs, Op-amps, and in their applications, Fundamentals of Electrical Engineering, and Waves and Oscillations. She is currently guiding 3 PhD students. She featured an interview in National Magazine Industrial Automation in March 2020. She was a resource person for a session of AST, STTP, and for 3 IUCEE webinars. It's my pleasure to welcome you, ma'am, on this occasion.
Thank you, Dr. Nagmani. Thank you.
Okay. I welcome all the students for this SigPro Project Expo. So let us start the session. First of all, I would like to ask the students with project ID 4 to start the presentation. So each student will be given 15 minutes of time to present their project and their question and answer. Is that okay with all of you? So paper ID 4, I think you can start.
Yes, ma'am. Is my screen visible?
Yes, ma, it is visible.
Okay. So, good morning, everyone. I'm Dharini from Ramaya Institute of Technology, Bangalore. So today I'm here to present my project, SeriMitra, an end-to-end AI-driven sericulture management system. This project was done under the guidance of Dr. C.G. Raghavendra, Associate Professor, Department of ECE, Ramaya Institute of Technology, Bangalore. So in today's presentation, I would be covering the problem statement, methodology, results, future work, and a few references. So starting off with, sericulture is one of the most important economic activities in developing countries like India. It employs over 8 million people, which makes it labor intensive, and at the same time, it creates massive employment opportunities to rural households and also promotes women empowerment. Detection and classification of diseases in silkworms is one of the most crucial steps in sericulture, as these unmonitored diseases leads to several damage to the health of the silkworms and subsequently leading to major economic losses to the farmers. So currently, there are disease identification methods for silkworms that are laboratory intensive and invasive in nature. And at the same time, it is also very expensive that isn't feasible for farmers to adopt. It is also necessary to continuously monitor the health of the silkworms and also maintain optimal environmental conditions to prevent major losses to the farmers. So all of this necessitates the adoption of AI-driven methods for the purpose of identifying and classifying diseases in silkworms in real time, enable remote and real-time monitoring, and this would help ensure increase the efficiency in sericulture. So moving on to the problem statement, silkworms are majorly prone to a variety of diseases belonging to viral, fungal, and bacterial categories. This is caused due to unfavorable environmental conditions, unhealthy rearing conditions, negligence of farmers, and feeding of these worms on diseased leaves. So once these worms are infected, it damages around 30 to 40% of the yield to the sericulture farmers. So the methods that currently exist are laboratory intensive, time consuming, non-spontaneous, and this requires technical expertise, which is not feasible for farmers to adopt. So some of the methods that currently exist are nucleic acid and PCR-based methods, nested PCR, ELISA production of monoclonal antibodies, and so on that are laboratory intensive. So currently, there are no provisions to detect the diseases in silkworms at an early stage or at a stage before they could occur. And at the same time, there are no provisions to monitor the external silkworm rearing conditions and provide this real-time data to the farmers remotely in order to prevent further losses in the sericulture sector. So this has led to, this has inspired us to find AI-driven solutions and help the sericulture farmers. So here we visited a few villages in and around Channapatna. So these villages extensively practice sericulture. So why we visited these villages is to understand the real life problems of sericulture farmers and also derive and also find out research problems that exist in the sericulture industry. So moving on to the methodology, here we have a Raspberry Pi core that is integrated with our computer vision model. It is also interfaced to a camera that would be placed in the silkworm rearing chambers and would continuously capture the silkworm activities. The Raspberry Pi is also interfaced to various sensor and actuation elements that take autonomous actions based on the sensor data as well as the data from the camera. All this data is remotely stored on cloud, and we've used Firebase for this purpose. And this data is remotely made available to the farmer through our farmer-friendly app called SeriMitra. So farmers would be able to remotely assess the silkworm rearing chambers, as well as the app also provides recommendations pertaining to better sericulture management practices. So here we have a flow chart of our sensor and actuation system. So based on the data that is recorded on the camera, an interrupt is sent to the core. So based on this interrupt, a disinfection system is initiated. So as soon as the camera senses an unhealthy worm, the disinfectant system is initiated and a pesticide is sprayed on the infected areas. And based on this data that is collected from the sensors, the actuation elements are initiated. And this is how our autonomous actuation system works based on the sensor data. So here we have our computer vision pipeline, basically. So the data set we've collected is through our field visits to different villages in and around Karnataka, as well as we obtained a few data sets from Department of Agriculture, GKVK. So what we did with this data set is first we pre-processed the data set according to our requirements, and then we classified our data into train and test basically for training and inference purposes. So our data set basically consists of two classes of silkworms, that is healthy class and the diseased class. So here we've trained around 9 to 10 machine learning models using our data set, and we've compared the accuracy of every model here. So these are basically machine learning classification algorithms. And as you can see, we've obtained the highest accuracy with random forest classifier and followed by decision tree and support vector machine. But in order to evaluate machine learning models, accuracy is not the only metric. So we moved on to other evaluation metrics, that is precision, recall, and F1 score. So based on these evaluation metrics, we found out that random forest classifier outperformed other classification algorithms. So we decided to move on with this classification algorithm. So why why random forest classifier proved to be better out of the other algorithms is because it is an ensemble learning algorithm in which the training data set is initially bootstrapped or divided into n training data samples, and decision trees are constructed for each of these samples. And finally, the output of each of these decision trees is averaged based on the voting mechanism, and the final prediction is made. And this is why it is called an ensemble learning algorithm. So here we have a few results that we obtained from the random forest classifier. The first is the result that we obtained when an image of a healthy silkworm was fed to the model. And the second one corresponds to when we fed a deceased silkworm image to the model. And we also plotted a confusion matrix in order to better visualize the performance of the model. So we found out that machine learning classification algorithms prove to be beneficial in a majority of the cases, but they have their own disadvantages. So when does this disadvantage arise? It's when the healthy silkworm and the deceased silkworm are found within a particular region in an image, or when they overlap upon each other. So in these cases, it becomes difficult for the machine learning algorithm to differentiate between healthy and deceased worms. So due to this limitation, we moved on to object detection based deep learning algorithms. So the first algorithm that we tried out was YOLO v4. So here we have plotted a few results of YOLO v4 algorithm. So the left-hand side denotes the healthy class and the right-hand side denotes the disease class. But YOLO v4-2 has its own disadvantages with respect to accuracy and inference time. So for applications pertaining to real-time monitoring, inference time plays a very important role, and we want the algorithms to perform really efficient and really well. So we found out that YOLO v4 has a larger inference time, which is a major drawback for real-time monitoring systems. So we moved on to YOLO v5. So YOLO v5 proved to be extremely robust, and it had a very short inference time. So these are the results that we plotted using YOLO v5. And we got a very robust model with a very good mean average precision score, very good precision and recall. So the precision that we obtained was 0.92 and recall was 0.968 with a mean average precision score of 0.989, which is a very good score for an object detection model. So here we implemented our model on videos too, not only images, because at the end of the day, our main aim is to implement our computer vision model on real-time videos, which would aid farmers to monitor the health of the silkworms in real time. So yeah, here we have here we have evaluated the performance of our YOLO v5 model, and these are the different plots with respect to training loss, test inference loss, and various metrics such as mean average precision and validation loss, etc. Yeah, so here we have a video of us implementing the computer vision model on real-time videos. Here we've implemented our model on a Raspberry Pi. So this was our implementation of our model for real-time videos. We implemented our model on a Raspberry Pi interfaced with a Pi camera module. So yeah, so as of now, we've implemented our computer vision model interface to a camera, and we've all so our future work would include interfacing of sensors for real-time monitoring of the environmental conditions in the silkworm rearing chamber, as well as integrate an actuation system, as I had told earlier. So this remotely collected data will be made available to the farmers in real time again, for efficient monitoring and tracking of the silkworm rearing chambers. A farmer-friendly app called Serimitra will be developed for farmers to easily keep track of the environmental parameters in the rearing chambers, as well as continuously trace the health of silkworms. This app So based on the collected data from the sensors, this app would also provide recommendations to the farmers for pertaining to effective sericulture management practices. So here, based on our findings, we've published a few papers. One of our papers was also published in IEEE ICDC ECE 2022. We also presented our work at a national event conducted by IEEE Pune section, and we were recognized as prize winners for the same. So here we have a few references, few papers that we referred to for our implementation of the work. We would like to extend our gratitude to IEEE Signal Processing Society, Bangalore chapter, and IEEE Bangalore section, as well as Ramaya Institute of Technology, Bangalore, for giving us an opportunity to present our project work and making this event a success. Thank you.
Madam, any question? I'll leave it to the jury members now for the question answer session. Murli sir and Renu Madhavi ma'am, you can ask question.
Thanks, Dharani, for a good presentation. I have a question here. The question is, so you are doing image processing to classify whether the worm is diseased or not, right?
Yes, sir.
So why cannot a farmer determine that just by visual inspection of the silkworms? Why does he need this application?
For visual inspection, the farmer always has to be present at the rearing chamber spot. But we are trying to provide this data remotely to the farmers, even when he's not present in the rearing chamber. Along with this information of whether the worm is infected or not, we also provide other environmental condition parameter information to the farmers remotely.
Okay. And my second question is, you mentioned a lot of pathological tests are required whether the worm is diseased or not.
Yes, sir.
And here the whole hypothesis is by visual inspection you can identify a silkworm is diseased or not.
Yes, sir.
Can you please elaborate a bit? Is it possible by visual inspection or it requires pathological tests here?
Sir, actually for now, we've built our model only for one disease, only for one class of disease, which are viral diseases. But in future, we plan to implement this algorithm for other pathological diseases as well. So,
Okay. So what is the feature set that basically classifies in your algorithm? Or you have just given images and you have done a supervised learning?
yeah, we've fed images belonging to two different classes, and we've fed this to our model. And this is how feature extraction is done to machine learning as well as object detection based models.
Okay, no, what I'm asking is if you visually want to classify, you told since it is an image based thing, right? So
Yes, sir.
what is that feature which is basically identifying that a worm has a disease?
It's basically the differences in the color of the skin. Basically, the differences in the texture of the skin on the surface of the silkworm as well as the color. And the camera that records the movement of the silkworms. The silkworms that are deceased are basically show slow movements. So these are the two ways in which we classify the disease, classify whether a silkworm has disease or not.
Okay, yeah, thank you very much.
Thank you, sir.
Renu Madhavi ma'am, if you have any questions, you can ask them.
Dharani, it was a good presentation. Congratulations for that. Am I audible?
Yes, ma'am.
Yeah. Actually, the procedure using design thinking techniques of finding what are the problems faced by the sericulture people, you have found out. Systematically, you have done it. But I have the questions little similar to what Murli sir has asked. You said it is a non-invasive detection, right?
Yes, ma'am.
when it is a non-invasive detection, now you told that it is only based on the color of the worm, right? So how
Color
many
as well
worms?
as color as well as
Uh,
movement of the worms.
okay, okay. How many worms will be there in a chamber, Dharini?
It depends on the size of the raring chamber, ma'am. If it's so approximately around 500 worms would be found in a medium-sized raring chamber.
Yeah, but with single camera, is it possible to cover all these 500 worms and
Uh,
their movement?
Yes, ma'am. For now, we've made a prototype with a Pi camera module that has a very small area of coverage. But when it would be actually implemented in the sericulture farms, we would opt for other cameras that have a wider area of coverage.
So you have to use maybe different number of cameras, right?
Yes, ma'am.
Okay. And in the slide 18, you gave some graphs, ma? Can you
Yes,
just
ma'am.
go to that slide? Just
Yes, ma'am.
want to
Sure.
know.
This one, ma'am.
Yes, yes, yes. So what is this x-axis, ma?
Ma'am,
X and y-axis?
x-axis is the number of epochs, and the
Uh-huh.
y-axis is the metric that's mentioned. For example, in a precision, for the fourth graph, x-axis denotes the number of epochs, and y-axis is the precision.
Oh, okay. So that loss, precision, those are all the metrics we are going to find out.
Those are the
Is it?
metrics, and x-axis represents the number of epochs.
Okay, okay. So that's fine. What will be the data size, ma?
Ma'am, for
For
now
the
for now we have a data set of around 1,800 images in total belonging to 2 classes. So it's approximately 900 in each of the class.
so only image classification you are doing, or what to do with that video clipping? Video also you are using, no?
Yes, ma'am. Initially, we did only image classification using the machine learning classification algorithms, but our end product would be implemented on real-time videos. So we moved on to object detection algorithms, and we implemented our YOLO V5 model on videos, on already available videos as well as real-time videos.
Okay. Okay, ma. Good work.
Thank you, ma'am.
Thank you, Dharini.
Thank you,
It
ma'am.
was a nice presentation. Okay. Next paper, next project presenter, project ID 9 can start presenting. Meantime, sir, Murali sir, as well as Renu Madhavi ma'am, both of you can start filling the evaluation sheet now. It is shared in your emails. I hope both of you have got it, received it.
We have received it. Yeah.
Okay, sir.
Yes.
I have received it. Yeah.
So the next paper presenter is with project ID 9. Can you start presenting?
Yes, ma'am.
Okay. First introduce yourself and then tell your project ID and then you can start presenting. Okay.
Yes, ma'am. Ma'am, can you see my screen?
Yeah, it is visible. Put it in the slideshow mode.
Okay. Okay, good morning to one and all present here. My name is Yukti and I'm from Oxford College of Engineering. So I'm here to present my project, that is food pressure analysis for podiatrist diagnosis. So to go to the introduction about the project, one of the interesting research field in biomedical engineering is to study about the food pressure distribution while standing, while walking and running. So the pressure distribution is essential to understand the effect on the human body and balancing criteria. So in order to ensure whether the health is in good condition or not, advanced technologies in biomedical engineering tries to invent something that can help us to find the treatment for human illness in food. So there are a lot of food diseases caused by pressure distribution on food. So such diseases can be prevented in early stage if people understand about the food pressure. So the intention of this study is about understanding the dynamic force distribution on human food. So by identifying the pressure distribution on the human food at different selected points of the foot, such as plantar flexion, dorsiflexion, inversion, and aversion, we could actually identify what disease the person actually has. So we all know that foot is a part of a human body that will sustain the highest pressure during standing. So analysis of foot plantar pressure distribution helps us in revealing the interface pressure between the foot plantar surface and the shoe sole. So in this study, we've basically considered 5 major factors to establish behavior of the human foot. So those 5 factors are body mass index, gender, type of arc, diabetic, and progressive foot deformity. So therefore, this experiment is conducted in order to know the pressure distribution based on the factors by using FBG sensors, that is fiber Bragg rating sensors. So
Are you still in the first slide, or you have, because I'm still just seeing the first slide.
sir, I'm still in the first slide.
Okay.
Okay, to know about how these factors actually affect, so the first one is the body mass index. The body mass index also affects the pressure distribution. As the body mass increases, the pressure on the foot increases. So as for gender, there is no significant difference in pattern of pressure distribution between males and females. While for the type of feet arc, different arc will give different locations of peak pressure. So the next factor is the diabetic factor. So pressures will distribute more to metatarsals and heel area, while for the progressive foot deformity factor, the pressure is usually distributed at metatarsals and the foot area and the toe area. So according to the literature survey, this is the literature survey that we have done for the project. So from the literature survey, we can draw that it is found that a person should distribute pressure homogeneously. But because of various factors, like I mentioned, those 5 different factors like body mass index and like the body mass index and like the gender, type of arc, and diabetic and progressive foot deformity, people have a tendency to exert more pressure on the heel side and the toe side. So based on the pressure exerted on the heel side and toe side, it can be predicted that a person has a different kind of illness. So the next one that we move on is the proposed method. So here we are taking different age group
Yukti,
and
Yukti, I think
yeah,
your slide is not moving.
just a second, ma'am. Ma'am, is it moving now?
Yes. Go to presentation mode.
Is it okay now, ma'am?
Please go to presentation mode.
It is in presentation mode actually.
No, we're not able to see that in presentation mode.
Just a second, ma'am. Ma'am, is it visible now? Ma'am, am I audible?
It is visible, ma.
Okay. So basically the proposed method for this is different age groups and genders were taken as input. Male and female with different average age group and weight were chosen as subjects as input, and subject steps on the pressure sensor device. So then the data were collected. So we've used the FBG sensors here, that is creating based on sensors. So signal processing, we will be applying different types of filters, namely low pass filter and high pass filter. So the signal processing is basically carried out by using MATLAB. The frequency of low pass filter is used in the range between 5 Hz to 12 Hz, and it is used for peak detection. Frequency of high pass filter is used in the range of 50 Hz to 100 Hz, and it is used to remove noise associated with the signal. So the reason for using both the filters is because the applied pressure will be less. So this is basically the experimental setup. So here we have chosen subjects based on the factors stepped on the foot pressure device to record the readings of the foot pressure. So here a FPG sensor is placed on thermocol sheets having slots where the FPGs will pass through. So over that we place a silicone rubber insole on the top of this thermocol sheet. So the test of the setup was done by applying forces on the insole, and before actually doing the setup, we have to make sure that the optical fiber is safe and ready for experimentation. So the positions of the pressure sensors are varied based on the subjects of the foot size. The pressure sensors will be taken at different locations on the sole for the study. So in addition, the location of 4 sensors were used for the study. The sensor is located at the plantar flexion, the second at the dorsiflexion, the third sensor at the inversion, and the fourth sensor at the eversion. So this is the experimental setup that we've used. And moving on to our first objective. The first objective is to find pressure due to different postural conditions. So we've taken four basic postural conditions, that is plantar flexion, dorsiflexion, inversion, and eversion. So that is shown on screen. That is the images of these are shown on screen. So according to this, we have placed the different types of. We have actually placed our foot on the positions that we have actually mentioned. So this is the foot position with respect to subject 1, and we've taken 2 subjects actually. This is with respect to subject 1, and this is with respect to the subject 2. So actually the other advantage of this is we can also identify the posture balance. So depending upon the arc of the foot, we can actually identify if a person has hollow or not. That is nothing but the loss of balance. So pressure can be detected by the arc of the foot, and posture balancing can also be detected by using this. So before starting this, I would like to also tell the steps for the conduction of this experiment. So we have tested up these we've tested this by applying different forces onto the insole, and we have connected the fiber to the interrogator laptop, and we have calibrated the FPG sensor, and we have observed the stable output. So this is the coding that we have used for the MATLAB, and this is the first waveform that we have obtained, that is wavelength against time, and the second one is. So this is the tabulations that we have done for different positions. One is for plantar flexion, the other one is for dorsiflexion, the other one is eversion and inversion. And we've calculated the center wavelength, change in wavelength, strain, sensitivity, and pressure using the formulas. So this is the result that we have observed, the different waveforms. And this is the shift in wavelength. This is the shift in wavelength for a flat foot, and this is for hollow foot. So here we have used the Rodanto software as our interrogator, and which was from California, that we got it for 9.5 lakh as from our guide, plus 2,300 USDs, and we got the funding from VGST for 25 lakhs. And the second object is to find pressure due to deformation of the foot. So these are the different 3 types of foots that we have taken into consideration, that is flat foot, normal foot, and hollow foot. So based on this, we have again done our trials and the tabulation for the same and obtained the results. So we have done these trials under Dr. Vasan, and this also helps us. This is like the first level of screening. So early detection can be done by using this method, and the doctor is in the process of doing human trials for this. So using FPG, we will be measuring normal pressure of different parts of foot regions. Normally, a pressure applied by a normal person and diseased person will not be the same. So in order to differentiate the pressure applied by normal person and diseased person, we are finding a range of pressure by FPG. So normal foot pressure and a defective foot pressure is different. So by using FPG and by observing the lambda length shift in fiber, we will be able to tell if a person is diseased or not diseased. So this is the future scope of this project, that is, pressure measurement is important in gait and posture research for diagnosing lower limb problems, footwear design, sport biomechanics, injury prevention, and other applications. So in-shoe sensors are flexible and embedded in the shoe such that the measurement reflects the interface between the foot and the shoe. The system is flexible, making it portable, which allows a wider variety of studies with different gait tasks, footwear designs, and terrains. Foot plantar systems have been applied to a number of areas, including rehabilitations, sports, and daily life. So there are a lot of foot diseases caused by pressure distribution on foot. So such diseases can be prevented in early stage if people understand more about foot pressure. So by these analysis, doctor can easily detect the fault associated with the patient. So these are the different references that we have used for this project. So with this, I conclude by extending our gratitude to IEEE and our college, Oxford College of Engineering, for making this event a grand success. And we would also like to thank our guide, Dr. Preeta Sharan ma'am, for helping us in this project. Thank you.
Thank you, Yukti. It was a wonderful presentation. So now I will hand over to Madam as well as Sir for any comments, question and answers, etc. Murli sir, any questions, sir?
Yeah, I just have a few questions.
Yes, sir.
Madam, what is your contribution in this work? Because I understood you got all the sensors and other things. You bought it from a company. So is it the MATLAB code that you have written, or what is your contribution in this work?
Sir, we have written the MATLAB code for the execution of this, sir.
Okay. Okay, so the entire setup was available to you, and you basically wrote the MATLAB code for doing the analysis.
Yes, sir.
That is your contribution.
Yes, sir.
Okay. And you were mentioning about some of the low pass and high pass filters. Can you elaborate why you need those filters and what is the role of those filters in your project? What exactly where you are using them?
Sir, we are using low pass and high pass filter to get the raw data, sir. The raw data of the subject and to plot the raw data of wavelength and time.
Okay, what is the frequency range of your data? Because I'm interested. What is the frequency of your sensor data that you are receiving?
Sir, it is 10 to the power 14, sir.
Okay, thank you.
Yukti?
Yes,
Am I
ma'am.
audible?
Yes, ma'am. Yes, ma'am.
It was a wonderful presentation. Yes, I have got only one doubt. Is there any similarity between the hollow foot and a female foot?
Ma'am, is there any similarity between?
Hollow foot, you have classified the foot, no? So there
Yes,
are three types. No? Is there any difference or is there any similarity between the female foot and the hollow foot?
Ma'am, actually there are no similarities between hollow foot and the female foot, ma'am. It is totally different, ma'am.
And did you say that this pressure, whatever strain you have measured, right? Have you used any strain sensors or only this with this grating thing?
Ma'am, we have only used the grating sensors, ma'am.
But how do you validate that whatever measured is correct, the strain and pressure measurements?
Ma'am, we have used the formulas to actually calculate time and sensitivity. And we have also verified it using electronic sensor, that is a load cell sensor, ma'am.
Okay, okay, okay.
Yukti, I have got one question, Yukti.
Yes, ma'am.
So you said that you have taken sample gesture of your foot, like that you have shown in the diagram, right?
Yes, ma'am. Yes, ma'am.
So I think so you have compared male and female. You have taken both from male as well as female.
Yes, ma'am.
Okay. So you have taken both male as well as female of the same age or different age?
Ma'am, we have taken actually average. We have not taken of the same age. We have taken different age groups.
Okay, that is what is my concern. Because this foot disease may come in any of age groups, right?
Yes, ma'am. True, ma'am.
So I think, yeah, all the age groups to be considered, I think for the
Yes, ma'am.
future work.
Yes, ma'am.
How many images or postures that you have evaluated or analyzed?
Ma'am, for now we have done it for 4 different postures. That is
Of
plantar
a same
flexion.
person, of the same person.
Yes, ma'am, of the same person. One
Okay.
is so for the same person, we have done it for 4 different postures. That is plantar flexion, dorsiflexion, inversion, and eversion.
Exactly. So I feel that data set has to be more like from the different persons, not from the same person. Okay. So I think
Okay.
you have taken the healthy person postures and you have evaluated few things. But I
Yes.
think that your data set has to be more. Like who has a
True,
foot disease also that you should have taken. Okay, that's
ma'am,
my
we've actually taken a
advice.
wide range. We have
A
taken
wide range
almost
that you
all.
should have taken.
Yes,
Yeah.
ma'am. But right now we went to physiotherapist actually to do the trials, and now under Dr. Vasan, human trial is actually going on, ma'am.
Okay, so that's what is my this one, because it's not possible to conclude with minimum postures with a few people. I think you have to go for wide variety of people so that I think it will be a good societal concern project. Okay, that's my
Yes,
piece
ma'am.
of advice. Thank
Okay,
you.
ma'am.
Thank you.
Thank you.
It was a wonderful presentation. So I will
Thank you.
the next project presenter, number 27. SigPro 27.
Yes.
Yeah, please introduce yourself and then tell your paper project ID and then proceed. Okay.
Okay, ma'am. 1 second. Just present. Okay, ma'am. Good morning, everyone. We are team 27 from Ramaya Institute of Technology, and today we'll be presenting our project titled as AI-powered smart trafficking system, which is done under the guidance of Dr. Agram S. So I'm sure that all of us have been stuck in traffic for at least 30 minutes. And while we are stuck in traffic, we do not usually switch off our AC or music systems, which results in more wastage of fuel. And almost 60% of Indians prefer traveling by road, which is a huge amount of vehicles, which causes a lot of traffic. And almost 20% more fuel is spent while we are just stuck in traffic, which leads to a lot of wastage of fuel and pollution. Therefore, we aim to redesign the traffic signal system, that is from static switching to signal switching, which can perform real-time signal monitoring and handling. Okay. Next slide. Okay, so if we take a look at the current scenario of traffic management, we see that the traffic congestion is increasing day by day, and it's becoming even more worse in the case of the metropolitan cities. If we look at the technology which is generally being used, it is generally a microcontroller 8051, which doesn't take any input of the traffic analysis or how much is the traffic density around. Thus, we will develop a system in taking the traffic density, and we have implemented it on the Jetson Nano for a complete end-to-end solution. Next slide. Okay, so basically our working is divided into 2 parts. Now the first part is the object detection. Now for object detection, we have basically used the YOLO V5 version. And after the object detection is done, it tells us how much is the traffic density, which we are then passing into our code, which tells us how much should be the traffic green line clearance signal. So if you look, first of all, we are taking the input images of video through the camera. Then, since we are using a pre-trained model, we are loading the weights in the classes. After detection and complete resizing of the image, we are going to get the complete traffic density. Then, on the basis of the traffic density obtained, we will decide that how much should be the lane clearance. So that's a complete overall methodology. Next slide. YOLO is a fast, accurate, real-time object detection algorithm. It divides the image into S cross S grids and predicts probability and boundary boxes for each grid. Boundary boxes are weighted to predict probabilities. Non-max suppression is used to select the most appropriate box from an object. It selects the boxes with maximum objectiveness and removes the one with high overlap. An image with the labeled output or labeled image as output is the output.
This model on Jetson Nano Developer Kit by NVIDIA. It is an integrated system used for object detection.
Shruti, please be louder.
Okay, ma'am. One second.
Okay.
Okay. Am I audible now?
Yeah.
Your voice is not clear.
Your voice is breaking, ma.
Just
I think Pavitra can mute your mic.
is it better now?
Yes, definitely. You
Okay.
can start.
You can see the results that we have obtained from this model. We have implemented this model on Jetson Nano Developer Kit by NVIDIA, which is an integrated system used for object detection and obtained successful detection for images, videos, and real-time video inputs. For images, as you can see, we have taken two different types of images, for example, like the left one with lower resolution, but the detection that was obtained for images was accurate. And in the right one, as you can see, that although the total number of objects detected was 88, but after non-maximum suppression, it has been reduced to 43. Non-maximum suppression is an algorithm that ignores overlapping bounding boxes and filters the prediction of detection. Next, you can see these are the video inputs and the outputs that have been obtained after detection. The video, each frame was successfully detected and works fine even if the speed of the video is increased. As you can see in the right one, the video has a greater increased speed than the previous one, but the detection that was obtained for the cars and the motor vehicles was with the same probability. Next, we tried using video inputs, which was real time. This is a real time video input from Bell Road, and the results were obtained with the same amount of accuracy and probability. This is a real-time video that we recorded and then put it as an input for a model.
So for our future possibilities, mainly we are considering green corridors, which is suppose an ambulance is approaching a signal, then the hardware will detect the ambulance and temporarily that particular lane will be open, bringing a temporary halt to all the other lanes so that the ambulance can pass without any problem. Also, parking lot allocation by simply displaying the number of free parking spots on the floor of suppose a mall or a hospital. By detecting the number of vehicles entering the building, we can avoid confusion and cluster, and for it is also used for better time management. So one of the challenges that we are facing is when there are huge vehicles, there might be a shadow cast on the smaller vehicles, so the accuracy may drop a little bit. Also, while implementation, the speed of detection might be reduced. So our main object was to fix the problem found in traffic so that there is no cluster and we can change to a smart trafficking system so that we do not have to wait in traffic for a longer period of time and we can pass through traffic without any problem. So we have successful detection of video and images is done and the model yields a desirable accurate result from the input feed, that is from the camera.
Okay, so these are the different references which we have used for our model. Okay. So at last, we want to thank SPS Bangalore section for giving us this opportunity. Thank you.
Thank you. Thank you, Shruti, and thank you, Shreya. It was a nice presentation. So over to you, Murali Deshpande, sir.
Hello, madam. My question is
Yes.
again along similar lines. So you mentioned this is NVIDIA's thing, right? NVIDIA is basically identifying the the
Yeah.
vehicle and other things. So what is your contribution here?
So actually, we are using the Jetson Nano Kit for a complete end-to-end application. We have not constrained our project just by implementing in our software, because in real time we need some hardware to implement it upon. So actually, we have done the pre-trained model we have used, but the complete implementation of Jetson Nano was actually done by us.
Which part was done?
The implementation on the hardware.
Okay, which hardware?
We have used Jetson Nano for this, which is basically an integrated system which is designed specifically for the AI applications.
Okay. So what was the effort in it? What did you actually do when you say you put it on the hardware?
So actually, if we see in this, we have used a pre-trained model. So loading of weights and getting all those configuration files, that was done. Then modifying our code in order to obtain how much should be the lane clearance time, that was done by us. And after that, interfacing it with the Jetson Nano Kit, that's what we have done.
Okay, how many lines of code did you write for this?
So it was probably something around 150 to 100, that's all. And different functions we have imported for it.
Okay. So you mentioned about the timer for efficiently handling the signals, right?
Yes,
So
sir.
have you developed any algorithm for that?
Sir, actually, mostly each car takes about 15 seconds to pass through a signal in India. Also, the distance between each car should at least be 2 seconds. So, accordingly, we have placed a timer. So, we have kept a minimum and a maximum timer, and in between, we have put like different timers so that accordingly traffic can open, the signal can open.
Okay. Yeah, thank you. Yeah, it's a very relevant problem. Thank you very much.
Sir, if you can, we can show the code implementation, sir.
Yeah, I would have loved to see a demo in case you have made a demo, right?
Okay, sir.
Yes, sir, we can show you that one.
Pavitra,
Yes, yes, ma'am. Just 1 minute.
it was a relevant presentation.
Thank you.
Before you give the demo, just can I ask you?
Yes, ma'am.
The other car should have a different.
Pavitra, please mute your mic.
Yeah. So, Pavitra, you told that there is a particular assumption of one car to the other car, right? What was that?
Yes, ma'am. So, according to studies shown that the distance between one car and the next car that is just behind it should be at least 2 to 3 seconds.
But in the Indian scenario, all the traffic road congestion where will be more, no? Oh, is it really possible in the Bangalore scenario?
Ma'am, actually, it will be maximum to 2 to 3 seconds. So accordingly, we have kept the timer by keeping it at the maximum. So like if one car is passing 2 seconds, so like 10 cars are passing in 20 seconds. So we have kept more timer so that the cars can pass.
But actually, have you did any observation or any study on field?
Actually, the video which we showed was the real-time video which we took on the Bell Road, and on that we got the required results.
But I'm just asking, is it only the Bell Road that will give you the standard values? Like, no, I'm just asking. Different junctions would be having different patterns, right?
Yes, ma'am.
I guess maybe way from one to the other. I guess that you'll be taking later.
Yes, ma'am. For now, we have considered the minimum and the maximum time, and accordingly, we have given the timers. Maybe in further studies, we might search for new algorithms and things so that we can come up with a better timing for the signal to be open.
Okay, ma'am. Okay.
Thank you, Pavitra and Shruti. Project ID. Please introduce yourself and tell the paper ID and then start presenting.
Hello, Nagmani ma'am. Am I audible?
Yes, you are audible, but a lot of
Yes.
noise is coming. Okay, if you are switching on two devices, I think echo will come. Switch off the other device if you are having, or you have kept your mobile near the laptop. You please keep it away. Okay. So now you can start presenting.
Yeah.
And then introduce yourself.
Hope my screen is visible to everyone.
Yes, it is visible.
Yes, ma'am. Good morning, everyone. This is Bhargava Videsai from RNS Institute of Technology. We will be presenting on the topic implementation of physical layer encryption for wireless communication systems. Our project ID is Signal Pro 31. Our guide is Sanjay Begankar sir. He is the assistant professor from Department of EC. We'll be going
Voice
through.
is not that audible, Bhargava. Can you please be?
Yes, sir. Hope I'm audible now.
Yeah.
Yeah. So basically, we chose this topic as one of the major concerns were rising in the pandemic session. That was cybersecurity and privacy of the people. The signal encryption has been there for decades and has been in practice for a very long time. But ever since the rise of the technology has happened, in parallel, there has been a technology rise which is breaking the system in order to give a better system for the future. So what we came across is that whenever we are trying to connect in a public hotspot system or a public Wi-Fi system, for example, in a cafe while we are working, the communication that happens on Wi-Fi is encrypted using WPA, WPA2 or WEP technologies. But all those technologies have been broken, and there are many possible ways of decrypting the data and identifying the information whatever is being transmitted, and hence there is a loss of privacy in the system. So what basically a hacker does is connect a small antenna that is about 100 200 rupees to this using the USB port, and collect all the information that is around in the air. The person just has to sit within the region of the Wi-Fi system, and that helps him identify and capture all the data, and the privacy of the people there is breached. So what we have introduced is encryption in the physical layer. That is because WPA, WPA2 and WEP technologies have been compromised. Even the recent WPA3 technology also has been compromised using the dragon blood attack. So what we thought is why not encrypt the analog signal which is being transmitted and confuse the eavesdropper in which frequency the actual transmission is happening. So by this, we'll be able to cover all the packet header information as well, the frequency in which the data is being transmitted, the size of the data that is being transmitted, the speed with which it is being transmitted, and all the other information. So that would be the main aim. The main aim was for us to develop the IEEE 802.11 standard, that is the standard used for wireless Wi-Fi communication systems, and the WBFM general system model has been developed, which also helps in audio transmission. So we have considered both audio and textual transmission of data. We can also implement this in the future scope for images and videos as well. So after the development of the general system model, we have implemented the four encryption techniques. Those are Vernum cipher, RSA encryption, logarithmic encryption, and FFT scrambler. We made implementation of this has been done on the GNU radio platform, which is an open source platform for simulation of wireless communication and signal processing. The codes for the encryption blocks have been written in Python. We made a comparative study of these and concluded on the encryption modules as the most ideal one. So, as I explained in the methodology, first we set up the standard wireless system. After which we studied the wireless encryption techniques which can be implemented. These encryption techniques are pre-existing but never have been implemented into the analog systems, analog signals, to be specific. And simulation of these techniques have been done for basic signals like sinusoidal signals, square wave signals. Then we implemented it onto the audio signals and finally to the wireless encryption, wireless communication systems. So analysis of these simulations have been obtained, and analysis is majorly based on the bit error and the interference noise that can be mitigated. So this is the general system block diagram. The encryption, all the encryption schemes, that is the VPSC, Vernum cipher, FFT scrambler, and the logarithmic encryption are happening in the frequency domain, and hence the analog signal is being encrypted in the frequency domain, transmitted converted back into time domain and transmitted. So if the eavesdropper is trying to identify the signal here, the person will not be will not be able to understand from which what is the actual signal that is being transmitted. Yes, so this is the general system block diagram for the Vernum cipher encryption. This we have given all these blocks. A few blocks have been present in the GNU radio platform, and a few blocks had to be hard coded. And those parts, that is the VPSC, the encryption parts majorly, are completely coded by our group. So this is the RSA encryption schemes. The outputs and the waveforms will be shown in the following session, in the following presentation. This is the logarithmic encryption module, and this is the FFT scrambler. The throttle is basically used to maintain the time synchronization during the simulations, because some simulations, as they are computational, do not get the same processing time as required. So in order to maintain all the synchronization, we are using the throttle block. So yes, as this is the WB Fm transceiver, so that is wideband frequency modulation technique. Here we are giving an audio signal as the input, transmitted through a channel, and before the transmission, after all the modulations and before it is being transmitted to the channel, the data is being encrypted. So and after the channel adds all the noise in the simulation, we get back the signal, and at the antenna stage, just after the antenna and before any other schemes, we do the decryption side, which then passes on to the low pass filter to remove the additional noise that is added in during the channel transmission. So this is the transceiver system with the encryption. As you can hear, this is the original audio. I hope the audio signal is audible. This is the actual signal, that is audio signal, that is supposed to be transmitted, and this is the actual signal that is being received, and after decryption and passing through the low pass filter, we hear the noise. With the noise mitigation techniques implemented, we have reduced and got back almost 98% of the original signal. So this is the 802.11 IEEE standard wireless communication system. Here the data will be padded in as input for as a textual format. All the data will be given with a header, which then is converted into symbols with tagging mechanism. and these symbols are then allotted into the carrier for the OFDM transmission. So basically OFDM technique is being implemented in the 802.11 standard. So after the OFDM carrier allocation happens and I mean, the pilot carriers have been inserted into the system initially. It is followed by the FFT operation and the cyclic prefix, and then at the receiver end, we have we get the moving average in order to like estimate the signal to the most accurate form. With the time delays being considered due to the Doppler effect that is being introduced by the channel. So we have introduced noise as well as the Doppler effect in the system. The decryption modules will also help us to identify these Doppler effect and noise and help us to mitigate these problems. And this is the actual hierarchical block. So the previous block is nothing but the physical layer hierarchical block of the Wi-Fi system, and the actual data that is transmitted would be the text format, the MAC address of the source and the destination along with the IP address would be attached to the header and sent to the system, and the Wireshark connections are also provided in order to capture the data and analyze it after it's being received. So this is the 802.11 IEEE standard data that is being transmitted in the channel. So the input signal, that is the time taken till here, is the amount of time it takes to process the data before it's being transmitted. And since transmission, the message would look like this. So this marker is done by the tags that we mentioned earlier here. Yes. Because we have added the tagged stream, we are able to see this tag at this point where the synchronization of the system happens. So basically, we give a small duration of time for the synchronization of the receiver, followed by the pilot carriers for the receiver to identify and synchronize with the transmitter, and followed by the original data will be transmitted. So once this goes through the encryption block, it's from the synchronization along and followed by the pilot symbols, as well as the data will be encrypted. So when the eavesdropper is trying to like intercept the data, the person will not be able to identify in which is the actual signal that is being transmitted. The general process of interception would be having a waterfall diagram in the frequency domain. So in order to identify which are the frequencies of operation, followed by the time domain characterization. So when they try to identify the frequency domain itself, there will be a lot of noise, and the person will not be able to identify from which frequency the data is being transmitted. So synchronization only at the receiver, because we would have added a small sequence which is identified by the receiver. The receiver will start decrypting the data and gets back the original actual transmitted signal and gives it to the top layers, that is the application. It reaches to the application layer. So in this Wi-Fi module, we have implemented 4 types of encoding schemes: BPSK, QPSK, 16 QAM and 64 QAM. These are the usual standards, and based on the requirement of the system, they are changed. So I have a small video which explains how the waveforms are obtained. Yes, so this is a sinusoidal signal which is given to the VPSC block, and at the encryption we can see that the frequencies here is distributed throughout the spectrum, but actual spectrum of the signal is very small, that is at a very particular point. And after this, we can pass it through the low pass filter and get back the original signal. This is the triangular signal that we have given to the frequency scrambler scheme. The frequency domain spectrum can be seen here, and because FFT scrambler changes the frequencies and introduces new frequencies, there is a shift in the level here. And after decryption, we get back the original frequency time signal and the frequency signal, frequency spectrum as received. And this is the logarithmic encryption. We have taken the square wave for this input, and as we can see, the in the time domain we have a large amplitude shifts because it might be prone to the noise, but because of the noise mitigation techniques that have been implemented in the encryption schemes, we would be getting back the original signal as we desired. So that would be logarithmic encryption. Yes. So this is the physical layer hierarchy that I was talking about. Yeah, this is the BPSK, QPSK, QAM modulation. We have also introduced the SNR signal to noise ratio that can be altered in the channel in order to efficiently analyze the system. At the transmitter end, for this, we have actually concluded from the bit error rate calculations that the Vernum cipher holds the best encryption scheme because it has the least amount of bit error rate after considering the key length of 1024 bits for all of the schemes. As the key length increases, the amount of processing will be more, and there will be a more delay in the system. In order to minimize the delay and the computational process, we have considered 1024 bits for encryption scheme. And to show you the outputs of the Vernum encryption, these are the outputs as I showed you earlier. The actual PDU and synchronization, pilot symbols, and the data after decryption, how it looks, and before the decryption happens, what is the difference. We can change the packet data length and also analyze the system, but for the waveform purpose, we haven't shown that part. And using the Python code for simulating the after simulating the entire process on Python, we have computed the value of bit error rate. With no encryption, it is 0, and with as we change the logarithm encryption schemes, we have different values for different encryption schemes. So VPSC gives the least amount of errors with the bit error rate to be most efficient one, and hence we conclude that VPSC encryption helps us to have a more secure communication. It helps us with the VPA. It helps us to maintain our privacy during communication, as well as maintain the confidentiality of the system. Thank you. And the future scope of this would be to embed the entire system into a small chip, which will be then used as a peripheral add-on to the Wi-Fi transmitter just before the antenna, which will help the communication to be more secure in a more secure fashion. These are the few references we have used for our project. Thank you.
Thank you for the presentation. It was a nice presentation. Over to you, sir.
Bhargava.
Thank you. Yes.
Thanks for the presentation. And I have one question which is related to one of the slides you presented. You are showing the bit error rate to be a function of the cryptography scheme you are using. But I'm bit I do not understand that. Can you please, because it is dependent on the modulation scheme, how is it dependent on the encryption algorithm you're using here?
Yes. So once when we do the encryption process happens in the analog to the analog signals. So the signals will be sampled, after which they will be quantized. They will those values will be undergoing the encryption scheme, because the data which is transmitted can be represented in the form like the data that is being transmitted is also prone to noise in the channel, and after the reception, what we have done is the amount of errors that are introduced during the encryption process as well as the channel, we have based on the error rate, there we like concluded with the bit error rate computation. I hope I answered the question.
Okay. And the other question I have is, you were mentioning you are doing some frequencies scrambling and other things. But today's
Yes, sir.
cryptography schemes are basically built around the key strength, basically.
Correct.
So any amount of processing you do is not going to increase the security. What is the basis of your work to say that security is better?
Yes. So the amount of key, the length of the key is important when we are doing the encryption in the application, the higher layers of the OSI model. But as we come in the physical layer, the data is transmitted in real time, and we have to collect the data in real time. So in order to have the most efficient transmission and reception while having a secure communication is can be done only by reducing the key length and reducing the processing time. So even though the key length is small, because the eavesdropper will not have the will not know that there is a physical layer encryption model that has been established, the person will not be able to identify which scheme of encryption has been there. The key lengths are basically large in the OSI models because the encryption schemes are a standard in the whole world. That is, AES standards have follow a particular length of key, and certain encryption schemes follow a certain length of bit length of the key. So because those are pre-standards that have already been established, this scheme, because it is a newly introduced system, the person at the eavesdropper won't be able to identify which scheme would be installed into the system.
Okay, thank you very much.
Thank you, sir.
Over to you,
Bhargava. Yeah. Bhargava,
Yes,
the presentation was good and good amount of work you had put. I have only one question related to this slide which is being displayed. You said you have selected the key length from some number to 1024, right?
Yeah.
The reason said some time there is some problem of the time, right? Can you tell me what is the time with the other bit rates, with the other key lengths?
As we increase the key lengths, usually for any propagation of signals, it requires a minimum of, in terms of milliseconds while the computation is happening. But as we increase the key length, the milliseconds will go into double digits and the triple digit values. So which cannot be accepted in a standard OFDM system. So here a maximum duration of encryption would take a maximum of 6 to 7 milliseconds. But increasing the milliseconds of processing to double digit or more would actually cause a delay and might also cause loss of data in transmission.
Okay, but have you checked what is the number? How many milliseconds or how many seconds that it has reached before and now?
After the computation, after length we haven't checked, but for till 2024 we have calculated it to be 6 to 7 milliseconds.
Okay, Bhargava. Okay, thank you.
Thank you.
Thank you, Bhargav. The next paper is 35. Are you ready?
Yes, ma'am.
Okay.
Can you see my screen?
Yeah, put it in the presentation mode.
Yes, ma'am, it is in presentation mode.
Yeah, okay. You can start presenting.
First of all, good morning to everyone present here. I'm Shreya Hasyagar, and today I'll be presenting my paper that is Underwater Image Refinement for Visual Perception, and my project ID is SigPro 35. Our internal guide is Ms. Shweta GN, who's an assistant professor in Department of ISC RNSIT. So when we talk about underwater, so basically for a long time cameras were analog, right? So that means that all the videos and images that were captured were on the film. So as the digital technology came into picture, the video and images, they were easy to capture, and all the video processing and image processing became very relevant. So when we talk about images, we only talk about images on land, or people even talk about astronomical images, but no one really understands that there's a whole different world underwater. So we have visually aided autonomous underwater vehicles and remotely operated vehicles that are used in order to capture all these underwater activities. We are trying to present you with the fully convolutional conditional GAN-based model, that is generative adversarial networks, that are used basically for real-time underwater image enhancement. So whatever model that we are trying to propose, so basically it can be used in applications like monitoring various marine activities, basically like if there is any species migrations or coral reefs, or inspection of cables or wreckages in the submarines, or underwater scene analysis, seabed mapping, and even like human robot collaborations. So these are some of the main applications that this GAN based model can be used in. Talking about the problem, what we face when we are trying to capture is that when it comes to underwater, right? Even though we have high-end best cameras, visual sensing becomes very difficult because of all the poor visibility, light refraction, absorption, and scattering, and there will be a lot of non-linear distortions in the captured images, and that becomes very difficult in tracking or detecting any images that are present, any object that are present underwater. And we all already know that light propagation will differ underwater than in the atmosphere. So the kind of images that you can see in this slide, that is basically covered with hue and very less visibility. And once we do know that there is some kind of images present, we can try and detect what and all different kind of species are present underwater. So the kind of methodology we are using here is by using UNet. So the main idea is that we have deformed images, and we are trying to improve those images with the help of GAN-based model. So in this GAN-based model, basically we have a source and some amount of noise. It can be anything like hue or less contrast images, and we are using a loss function, conditional adversarial loss function, which has been presented in this slide. And the basic concept is that the generator will try to minimize this loss, whereas the discriminator will try to maximize it. So the different kinds of properties that we are trying to investigate here are global similarity, image content, local texture, and style. Talking about the generator architecture, we have a generator that is designed in order to improve the UNet architecture. So the generator is basically an encoder-decoder architecture, and the specific whatever kind of generator we are trying to use, it has been seen in this slide. So basically the input of the generator is at the left, and you can see that the size of the image is that 256 into 256, and there are 3 channels. And these are like 5-layer multi-channel feature images, and they are obtained through 4 into 4 convolutional kernel and non-linear batch normalization operations. So the main function that this thing does of this encoder is that it does continuous downsampling, and it reduces the image size, and it extracts the shallow information of the image. So the right half of the generator is a decoder. So it has four different mixed rectangles, if you can see, and basically this multi-channel feature, it is in the decoder, is obtained through 4x4 convolutional kernel deconvolution, and we also use batch normalization in this process. So this generator is different from traditional unit because it uses very few parameters, and it only needs like 256 feature map in the size of 8x8. Talking about the discriminator, it uses the method of Markovian patch. So that is Markovian patch GAN is a fully convolutional network. So the output of each layer in patch GAN represents a original image, and we have the image size, as you can see, is 256 into 256, and the number of channels, that is truth image as well as generated image. So as you can see, the output is a 16 into 16 vector, and this is based on the 3 into 3 convolutional kernel size. We all talked about the complete theory that is behind this. If you can see the results, you can see that on the upper side, on the topper side, you can see the kind of images that we are given. We use a data set called as EUVP, which basically has around like 20,000 paired and unpaired images. So paired images are basically images which are good in quality, but they don't really have all the kind of clarity that we require. Unpaired images are the ones which have both good and bad kind of images. So we are trying to enhance those images, and as you can see in the bottom row, you can see that using we can basically see what are the different kinds of objects that are present, and we can actually detect what is the object from the background. This slide basically is an output which basically shows the training of both unpaired and paired images using this GAN. We have used TensorFlow and PyTorch in order to train this, and this basically tells about the different discriminator and generator model architecture that we have incorporated in our project. When you see this slide, you can see that it basically tells the time taken and at different frame per second, and we have tested this model, and what we have found out is that it uses simple architecture, but it gives accurate and almost same images as that of the existing models at a faster rate. So when we did test this model, we found out that the true color global contrast has been enhanced in the output images, as well as the green hue that was present has been removed, and the sharpness has been enhanced. And in these pictures, you can see that whatever object that we had detected, these are the ones that has been enhanced. So on the left, on your right side, you can see that there have been images with the RGB color, and those same amount, the same areas that have been detected here are the ones that has been enhanced. We did a qualitative and quantitative evaluations using a metrics called as SSIM and PSNR, and we found out that the mean for the enhanced images are more compared to the input UIQMs, which basically means that the enhanced images do give better results. Concluding our project, so what we have tried to do is to get a real-time convolutional GAN-based model which enhances the underwater images but by using very simpler architecture than the ones that are already present. And we are also trying to present you with the large scale data set, which contains both paired and unpaired collection of underwater images. And we are also trying to demonstrate the effectiveness of improving the underwater activities like object detections or human body pose estimation performances. When we did find out all the images, we found out that the global color and local texture and style information were enhanced. I'd like to thank IEEE Signal Processing Society and RNSIT for giving us this wonderful opportunity to present our paper in front of you. Thank you.
Thank you, Shreya. It was a wonderful presentation. Over to you, Murali Mohan.
So what is the signal to noise improvement you are achieving for different input signal to noise ratios in your with your technique?
So we found out that as you can see here, the SSIM for we have used for 115 samples, and we found out that the mean is lesser. Sorry, mean is more when compared to the standard deviations.
No. What I'm asking is there is an input signal to noise ratio, right? Probably you might have for your image. And with your enhancement technique, what is the improvement you're achieving?
So yes, sir, the noise is reduced almost to point. It is reduced to a very minimum level compared to the input images.
Okay, and what is the improvement in the classification rate? You are mentioning it is helping us in the classification, right? So what was the, with your input images, what was the classification? And what is the new classification, right classification percentage you are achieving with your method?
So we are trying to enhance both kind of paired and unpaired images. That is what I was trying to say.
Okay.
Irrespective of irrespective of the images that is being captured in the depth or near the water, it doesn't really consider what kind of images or what is the depth. It just basically enhances all those images to a right, to the available enhancement.
Okay. Now, can you please go to that image with the tortoise, please? Because here you are basically saying you are able to classify better, right? The red image in the end.
Yes, sir. These are the images that basically detects what. So basically, if there is a lot of hue that we have, we cannot really see what images it is. So we are first trying to detect those images and then enhance the same images in the same areas.
Okay. 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 So what is your contribution and here?
Yes, sir. So basically, we have, as I said, we have implemented this whole thing by writing all the code and trying to compare them between different models. Like there are different models like UGAN and what we have proposed, and all these things we have tried to compare them, and we found out that accuracy is almost the same. So we have not only limited this just for one kind of data set. We have also used different kinds of data set that is available, like the one that I spoke was EUVP. There was also availability of UFO. So we have trained this model for with both kinds of data sets. And we have found that the pictures, it has increased, like the enhanced images have better mean.
Thank you very much.
Thank you, sir.
Madam, if you have any question, you can ask.
Shreya, it was a good presentation. My only question is that you have taken different data sets for your analysis, right? You have checked it for the classification, all those things,
Yes,
right?
ma'am.
So, was it giving the same result or different results of accuracy with different
It is
data
giving,
sets?
yeah. So what we try to do is we try to, irrespective of whatever the size of the data, I mean images, we are trying to get it into a same image and like same size before processing it, and then we convert it back to the same. So the accuracy is almost same, ma'am, for all kinds of data sets.
Thank you.
Thank you.
Thank you, Shreya. We have the last three. Can you please kindly share the screen and start presenting? First, you introduce yourself and then start presenting. Hello? Am I audible?
You are audible, madam.
You are audible, madam.
Okay. Paper presenter with the project ID 33 is not present here. Everybody is done with your presentations? Ajay, did you present?
Yes, ma'am. I am from team 4.
Okay, Shreya finished, right? Bhargav finished. Pavitra finished and Shruti finished. Shweta? Shweta, you finished?
I'm from Shreya's team, ma'am. I'm a guide of Shreya's team.
Oh, thank you, ma'am. Thank you for joining.
Okay, ma'am.
Okay, Supriya, you finished, right? Supriya?
Yes, ma'am. Same team, 35.
Okay,
35
Vaishnavi
team.
also finished, right? Yukti finished. Okay, I think team 33 did not join, ma'am. Did you know that? Hello, ma'am. Okay, then if everything is done, I think we can conclude the session. Yes, ma'am. Renu Madhu, ma'am. Can we conclude the session?
Yeah, Nagmani is only to confirm that is 33 from Sahyadri College is absent, and the 35 is the one who has presented just now.
We have presented just now. Yes, ma'am.
Yes, ma'am. Yes.
33 is absent. 4, 9, 27, 31, and 35 is presented, ma'am.
Yes, ma'am.
5 papers, 5 projects presented. 1 is absent.
Yes.
33 is absent. Yes, ma'am.
Yes,
Okay.
ma'am.
Yes. Okay. Thank you, all the project presenters. Thanks for your presentations and for your enthusiasm and good presentations. And all the projects were very good and well presented. Thank you all for joining. And a special thanks to our jury members, Dr. C.H. Renumadhavi ma'am. I personally thank you for accepting our invitation and for agreeing to be the jury member for the SigPro 2022 Project Expo, which is hosted from IEEE SPS Bangalore chapter. Thank you so much, ma'am. Thank you very much.
Thank you, Nagmani. Pleasure is mine.
Yeah. Thank you, Murli Mohan Deshpande sir from NXP Semiconductors for readily agreeing and accepting our invitation to be the jury member of this SigPro Project Expo hosted by IEEE SPS Bangalore section. Thank you very much, sir. We would like to have collaboration in future as well. Thanks a lot, sir.
Thank you, madam, and thanks to all the participants. Everybody presented really well.
Okay. Thank you all. Now we will conclude the session. Thank you, sir. Thank you, ma'am. Thank you, all the students.
Thank you, one and all.
Thank you.
Thank you, ma'am.
Thank you. Bye-bye.